Hello everyone. In this video, I'm going to discuss about data structure question. Okay. So first, let me discuss unit by unit. First, I will discuss the syllabus. Then, what are the questions you may get in it? Okay. So I will discuss best case as well worst case. Both the cases I will discuss. Okay. See here in first unit. See introduction to data structures, abstract data types, linear list, so single linked list implementation, and stack and queue. So here in this first unit, okay, so in this first unit we have two parts. Okay, so first part we have three questions: stack, next single linked list. Okay, single linked list. So these two are the best cases in first part. These two are the best cases in first part. Definitely 90% you will get either question from stack or single element list. Okay, from stack or single element list. Next, you have choice question, right? So choice question best case is infix to postfix conversion. Okay, infix to postfix conversion and postfix what expression evaluation. Postfix. Okay, for postfix expression evaluation. So totally here stack, single linked list, infix to postfix expression, infix to prefix. Okay, infix to postfix and the infix to prefix. Next to postfix prefix, what expression evaluation. Totally six questions. Okay, so if you read these six questions, easily you can attempt one question. So this is the best case. So then what is the worst case? Worst case is Q. Okay, worst case is Q. So there is what less number of chances to get question from Q. Okay, from Q, so you will get a question, but you have very less chance. Okay, so mostly you will get say stack, single linked list, next infix to postfix, infix to prefix, next postfix evaluation and prefix expression evaluation. Okay, so these are the questions. Okay, you may get from unit one. Okay, so here see, go to the question bank. Okay, go to the question bank. See here, explain about push and pop operations of stack using linked list. See, next, write an algorithm push and pop an element from linked stack. Next, see here, list various operations of linked list and explain how to insert a node anywhere in the linked list. So like add first, add last, okay, add middle. Like this, we have different functions now. So the he's asking to what explain those. See next, write an algorithm to insert a new node at the beginning, at the end of single linked list. Here he is asking specific. Okay, here he is asking all, including with middle also. See, define stack, explain various what explain the operations of stack with an example. Okay, so here question is same, but the way of asking the question is different. Okay, the way of asking the question is different. See, define single linked list, write structure of single linked list with need states. See, discuss brief about single linked list. See, he is asking same question but in different ways. Okay. Next, see, explain procedure to convert infix to postfix. See, mostly, so I have seen question papers from last 6 years. So every time, okay, only what infix to postfix expression. Even he is not asking question like infix to prefix. Mostly asking what infix to postfix only. See, convert the following infix to postfix expression. So this is another. So simply he is changing the what expression. That's it. The way of asking question is same. See, write an algorithm to evaluating already I told evaluating prefix and postfix expressions. Even he is not asking prefix. Mostly he is asking postfix, infix to postfix and postfix expression evaluation. See, so here stack, next linked list, next infix to postfix, okay, infix to postfix, three questions, and postfix expression evaluation. Okay, postfix expression evaluation. Totally five questions. If you read these five questions, definitely you will okay, what get one question. Okay, definitely you will get one question for sure. Okay. So all these are same questions, but he is asking different. See, define data structure, discuss different types of data structures and their applications. This is very basic questions. Okay. See, we have linear data structures and a non-linear data structures. No? So this is very basic introduction he is asking. Sometimes he may ask questions like this. This is not comes under what worst case. Okay. This is also best case. See, write an algorithm of insert and deletion operation of singly linked list. Very easy questions. Okay. Okay, so if you read these five questions, you can easily attempt one question from unit one. Okay, so this is R22 regulation. Okay, R22 regulation. Next worst case. See, describe conditions of overflow, underflow in a queue. See, here even we can't say that Q is worst case, but mostly the how they are asking the question based on that I am telling Q is worst case. So mostly asking questions from linked list and stack. Okay. So this is one worst case question and discuss applications of queues, explain the operations of queues. Actually, Q question is very easy, but the question is asking what array. Okay. So explain basic operations of queue with pseudocode. So he's asking but questions different. See, write a program to implement stack operations. Actually, so why I have written this stack in worst case means he is asking the program. So here program also asking very rare. Okay, so that's why I have written what in the worst case. Okay, so while preparing for a stack, if you prepare program, so that will be good. Then we can move into the best case. Okay. So most of the students what skip what programs. So that's why I have written what in the worst case. Okay. So write a program, C program to convert infix to postfix expression. Already this question also actually theoretically this is best case, but here the asking what program knows that's why I have written in the worst case. Okay. Next, what are the advantages and disadvantages of representing stack or queue by a linked list? So this is I have written in the worst case. Why? Because so you have if you have what deep knowledge on this, then only you are able to answer this question. Okay. So write a program. Sorry, write a function to count the number of nodes in the linked list. So you have to write some what a program to count the actually very easy. So if you are familiar with program, you can easily write this question. Yeah. So you write a function to concatenate two circular linked lists. Actually, in a lab syllabus, you have W linked list and circular linked list. So mostly those questions are not asked in the what, question paper, but sometimes you may get what circular and the W linked list. See, that's why I have written. So rarely, only just 5%. Okay, worst case, you will get circular linked list and double linked list. Okay, so this is about week one. Sorry, unit two. Next, unit two. See, in unit two, so gunshot question of part one is skip list without any hesitation. 95%. Okay, 95% you will get a question from skip list. Definitely, definitely 95% you will get what skip list representation. Okay, so if you gone through any previous question papers, definitely you will get this skip list. So if you refer 10 question papers, at least nine question papers, okay, has what a skip list representation. Okay, so in second part we have collision resolution techniques. Okay, so linear probing, quadratic probing, double hashing, rehashing, like this we have different what okay, collision resolution techniques. So those collision resolution techniques you have to what prepare. It's very easy actually. Okay, you no need to what worry about this. Why? Because what technique to technique, only the hash function is different. Okay, hash function is different. So you may get questions on hash functions also. We have different hash functions, so you will get a question from hash functions. Mostly 90% you will get collision resolution techniques only. 10%, okay, you may get hash functions. Okay, hash functions. Mostly you will get questions from collision resolution techniques. Okay, so see, in first part, skip list, gunshot question. Okay, gunshot question. In second part, okay, so in first part, skip list, and second part, collision resolution techniques. Okay, see here, demonstrate skip list representation of a dictionary. Explain about, explain in detail about skip lists in data structures. Explain operations of the skip list representation. Write an algorithm for implementing what see here. So these three are what related to skip list only. Definitely 95% you will get skip list. Okay. So I can say 100% also, but we can't say sometimes. Okay, after it is not good, right? So that's why. Okay, so I'm telling 95%. Okay, so here explain algorithm for implementing quadratic probing. So see here, mostly the question is asked to write what collision resolution techniques, but if uh, the question asked individually to write particular collision resolution technique, then the question is coming from quadratic probing mostly. Okay, individual what technique is asking this quadratic probing. I have seen 90%. Okay, so quadratic probing they are asking. Okay, so but it's better to prepare all. Why? Because technique to technique, collision resolution technique, only the hash function is different. Okay, whenever there is an collision, so how to find out alternative position in the hash table. Okay, by using different hash functions for different. Okay, yeah, see, uh, see, discuss hash functions. Already I told. So you will get sometimes the hash functions also what just 50%. They're asking, but these hash functions here you have to read, right? Why? Because these hash functions you are using in the protocol is the resolution. Next, so you no need to worry about questions. See, very easy best case questions. Uh, See, worst case I have written, see, linear probing and the open addressing. Say, justify your answer. Actually, so you have to compare these. So you have to compare these two techniques, and you have to justify your answer. Actually, these type of questions, if you answer, definitely they will give marks. Definitely they will give marks. Okay, so for suppose 10 marks, right? So if you write your opinion on this question, definitely you will get at least 8 marks. But don't write what nonsense content. Okay, just you have to what compare this linear programming and open enders, these two, and write your you have to justify your answer in your own words. Definitely you will get 8 marks. So try to write questions, attempt these type of questions. Okay, why I have written in the worst case means see, most of the students not able to write these type of questions. That's why I have written in the worst case. But if you are very good uh, in comparing different techniques, then you can easily answer. So I'm telling, right. So for 10 marks, definitely you will get 8 marks. So if you compare, if you write these type of questions, okay. And list and explain advantage of extendable hashing. Okay. So this extendable hashing is also there. Okay. So this you will get only 5%. Definitely. I have seen. So I refer to 10 question papers. Among these 10 question papers, I have seen this extendable hashing will be only one question. That's why I have written. Okay. And this type of question also I have seen in the only one. Okay. So this is about week 2. Sorry, unit 2. Next, unit 3. Okay. So unit 3. See, unit 3, we have trees, right? So trees and tree traverses. Trees and tree traverses. Actually, here, tree traversals are not mentioned, but in your lab program, you have tree traversals. Okay. So tree traversals is one question. Okay. So I'm writing this tree traversal as a worst. Why? Because this is from lab. Okay. This is from lab. Okay. So lab program. So next here, totally we have six trees. Okay. So binary search tree, AVL tree, okay, red black tree, splay tree, okay, and the B comma baby steps. Okay. So these two are worst case. Okay. These two are worst case and the best case these four. So if you prepare these four these four trees, then you can easily attempt the question in unit. Even you no need to go for tree traversals and B clusters. Okay, so if I referred 10 question papers, out of these 10, 8 papers, okay, has this binary search tree, AVL tree, red black tree, and split tree. Even you get these worst case questions, definitely among these four trees, definitely you will get one choice question. Okay. So simply in unit 3, if you prepare binary search tree, AVL tree, red black tree, and display tree, these four trees, insertion, deletion, and searching, you can easily attempt the question. You can easily attempt the question. Okay. So let me go for question. See, see here, illustrate search operation on binary search tree. Very easy question. Okay. Write an algorithm to delete an element from the binary search tree. Already told. So every tree has insertion, deletion, and search. Okay. I explained briefly about binary search trees. See, the way of asking question is different. Write breadth first search algorithm. Sorry, this is from week 4. Sorry, unit 4. Okay. This is unit 4. I will discuss later. Mm. With suitable examples, illustrate left to right rotations on avial trees. Okay. Differentiate between splay tree and red black tree. Okay. Very easy. If you are familiar with these two, then you can easily write the question. Next, construct a splay tree for the following list of elements. So already I told splay tree, red black tree, avial tree, and binary search tree. See, discuss in detail about what are red black trees. See, write an algorithm of single rotation and double rotation of avial tree. Explains playing operations of splay tree with an example. Write algorithms for rotation. See, here the way of asking the rotations on of avial tree is different. See, three times, one, two, three times. Okay. Next, what is binary search tree? Write an algorithm for inserting, deleting a node in a binary search tree. See, write a short note on avial trees and red black trees. See, develop a binary search tree resulting after inserting the following integer keys. Okay, so he's asking to construct a binary tree using these what keys. After that, he is asking to do this. What? Check whether tree is almost complete or not. And determine height of the tree. Next, write post order and pre-order terms. So like this, sometimes he may ask you questions like this also. Okay. So all these are best case. See in best case, okay. See binary search tree, AVL tree. Okay. AVL tree, red block tree, and split. So if you prepare these four, easily you can attempt the question without any hesitation, including choice also. Sometimes 80% you will attempt question 80% if you prepare for these trees. Okay, these four trees. Next, worst case questions. See, write in order, pre-order, and post-order traversals of binary tree. Okay. So actually, this is also very easy. But why I have written in means this is lab. Okay, lab program. Okay. Yeah. Next, construct regulatory with the following elements, and he's asking to delete element. See, deletion of regulatory is not that much easy. We have 6 cases to delete an element from what red black tree. So that's why I have written in the worst case. So if you are familiar with the deletion in red black tree, then you can easily what answer for this question. Okay. Yeah. Construct B tree. See, among 10 question papers, only one, okay, question paper, I got this B. Only one paper has this B. Even B plus 3, I have not seen in the what any question paper. So very worst case. Okay, B and B plus 3. Next, unit 4. Okay. First, let me discuss what syllabus. See, unit 4 is also very easy. So in unit 4, first part, we have what only two what we call topics. Only two topics. So graph implementation methods. Okay, graph adjacency matrix. So like this, we have three representations graph. So from those representations, so you may get one question. So very easy, those three. And graph traversal methods, DFS or BFS. Okay. So BFS, DFS, and a graph implementation methods. Okay. So if you prepare these questions, you will get one question definitely. So mostly 95% you will get DFS or BFS. That's for sure. And apart from that, see here, you will get 90% what this merges are, and remaining 10% what heap and what fix are. Okay. Even external sorting, I'm not expecting. Even external sorting, I'm not expecting. So this is very, very worst case, external sorting. So 90% you will get what a merge sort. Okay. So if you prepare what quick sort, heap sort, and a merge sort, these three, and a BFS and DFS, BFS and DFS, then easily you can attempt the question. Only 5 questions you need to prepare: BFS, DFS, and merge sort, quick sort, heap sort. These three sorting techniques and BFS and DFS. Okay. See, I have written best case. So in best case, see, a comparison of depth for search DFS and BFS. Write an algorithm for what merge sort and explain with suitable examples. See, 90%. Okay. In second part, you will get merge sort. Okay. See, discuss representation of graph using arrays and linkers. Already I discussed. So graph implementation methods. Next, see what is graph. Explain properties of graphs. So some graph terminology is there now. So very basic. So without graph terminology, okay, you can't go in detail, right? So sometimes you may ask question like this. So you will what score more if you get these type of questions. Very basic questions, right? Yeah. So see how a graph is traversed using depth first search. See, right algorithms, depth first search. Again, different techniques used to represent a graph in computer. See, graph representation again is asking. Explain graph traversal with an example. See, DFS mostly. Okay. Next, explain various graph representations. Okay. So graph representations. Okay. Graph representations and traversals. Only these two topics you have to prepare. Okay. Then you can easily attempt the question from week 4. This is what main question. And choice question you may get like this. Okay. Sorry, medstart also. Okay. See here. Mostly among quick and heap, mostly is asking what this heap. Okay. See quick heap. Next, compare and contrast different sorting techniques. See heap, quick. Okay. Quick and external sorting. So this is very worst case external sorting. Already I told. Okay. So mostly among the heap, quick. Okay, heap and quick 70% quick heap you will get, and this is worst case. I'm talking about worst case, and 30% you are getting what quick. So this is very very rare case. That's not sorting. But action sorting, you no need to worry. Actually, this is theoretical. Okay, so you have only theory. So after preparing for these what sorting techniques, please look at this external sorting. So it won't take much time. Why? Because you don't need to spend what more time, and you don't need to what think much about this external sorting. This is very what, theoretical. Okay, why we are going for external sorting technique? Even we have this what a heat sort, met sort, and effects. Why we are going for external sorting? Okay, and next to unit 5. So unit 5 also very very easy. Okay, so unit 5. Uh, see, in unit 5 pattern matching. Completely about pattern matching. See here in pattern matching we have three algorithms. So among these three we have brute force and KMP. See, actually we have Boyer-Moore also. I have referred written question papers. Mostly 80% you are getting KMP, Knuth-Morris algorithm, and 20% you are getting what a brute force algorithm. And I have not seen this Boyer-Moore algorithm when I referred these 10 questions. At least one time I have not seen this Boyer. And this price. Okay. In this price also, I have not seen this suffix price. Only I have seen this standard and the compressed price. That's it. This standard price mostly 70%. Okay, you will get this standard. See here, doesn't matter. Okay, how much percentage this price are coming, but you have to prepare all. Why? Because price is very very easy concept when compared to pattern matching algorithms. Okay. In pattern matching algorithms, already I told brute force and Knuth Morris. These two are very, very what important and very easy also. Okay. So in Knuth Morris, okay, I think you have LPS table. Okay. So generating this LPS table somewhat difficult. You feel. Okay. So next to Boyer. Okay. So very easy actually. You no need to skip any topic in the what weeks. Sorry, unit 5. Unit 5 you no need to skip any. Why? Because very easy actually. See, best case questions I have written here. See, Knuth Morris KMT. Okay, so Knuth Morris Pratt. So in short, we are calling it as KMT and brute force. See here 80%. Okay, so this is 20%. Okay, and see here compressed price and standard price. Okay, explain brief about the price we can accept. Okay, see, very easy. In 15 minutes, I have given best case questions only five types. That's it, five questions. And what are the worst case? Differentiate, sorry, difference between trees and ties. Sometimes the question may come like this. And draw flow chart for KNT algorithm. Okay. So sometimes he may ask the questions like this. Okay, KNT algorithm. So try to prepare what a flow chart for KNT algorithm in worst case. In worst case. So this is what total okay, 5 units what question bank. 5 units question bank. So you can easily predict what how questions you will get in external exam. Okay. So for autonomous what colleges also you can follow this question. Okay. So please mail to my mail ID. So if you want this question. So this is prepared by me. So I have taken a reference of what the previous question papers of JNT. Okay. So even autonomous colleges following this syllabus. No? So definitely you will get questions from this question, right? Okay. So 90% I'm assuring that. So if you prepare best case questions of this question bank, so you can easily attempt the questions. See, don't what panic by seeing these many number of questions. So just the way of asking the question is different, but mostly questions are same. Okay. So thanks for watching. Please subscribe my channel, and I will make more videos like this. Okay. Thanks, everyone.